everybody. In this video, we're going to be talking about the division algorithms for whole numbers. So when you're teaching long division, a lot of people that I've met have struggled with long division, and they're like, oh, I can't remember how to do that. But I've found that if you teach it in a visual way, it makes it so much easier to understand the process of why it works. So, and also to remember what all the steps are. So if we wanted to visualize the process of doing 461 divided by 3, I would first represent the number that I want to divide. So I'm going to have 1, 2, 3, 4 hundreds, and then I'm going to have 6 tens. So here's 1 10, 2, 3, 4, 5, 6 tens, and then 1 1. And ultimately what I want to do is I want to divide this up into 3 groups. So remember, there's 2 different ways to look at division. You can either think about it as dividing the number into 3 groups and you figure out how much is in each group. That's the sharing model. Or there's the measurement model where you take the number and you split it up into groups of size 3. So I'm going to be using the sharing model for this visualization, where I'm going to split 461 into 3 groups. So if I wanted to split this up equally into 3 groups, I could start off with my biggest place value and I could say, well, if I split my 400s up into 3 groups, I have enough hundreds that I can put 100 in each of my groups. But I don't have enough hundreds to put 2 in each group. So the way that I'm going to write that is a 100 in my answer. And I'm going to say, okay, well, when I put 100 into my 3 different groups, that means that I used up 3 of my hundreds. So I'm going to subtract those 3 hundreds, and that leaves me with 161. That still needs to be divided. So I have this 100, my 6 tens, and my 1 that still need to be divided. But my 100 is not going to be able to be split up into the 3 groups unless I exchange it for 10 tens. So I'm going to break that up into 10 tens, and then I'm going to split my tens up. And since I have 16 tens, because I had 6 originally, then plus the 10 that I regrouped from my 100, 16 tens divided into 3 groups should give me enough that I can put 5 tens in each group. So we'll look and see if that works out. But since 3 times 5 equals 15, we should have enough tens to put 5 in each group. And when you're teaching this to your students, you can have them make predictions of how much they think will be in each group, which will help them practice their division tables, I guess. So when we do this, we do end up with 5 in each group. And so that means that I can have 50 in my answer. And when I divided up 5 tens into my 3 groups, that took care of 15 of my tens, or 150 of my number that I'm trying to divide up. So I'm going to subtract 150, which means that I have 11 left to divide. And you can see that visually because I have 1 10 and 1 1. And this 1 10 can't be divided up into the groups unless I exchange it. So I'm going to exchange that for 10 ones. So now I have a total of 11 ones that I want to divide into 3 piles. So you could ask your students to predict, okay, well, how many ones are going to end up in each group? And since 3 times 3 equals 9, but 3 times 4 equals 12, and we don't have enough ones to put, we only have 11 ones, not 12 ones, that tells us that we're going to be able to put 3 ones in each one of these groups. So when I do that, I can see I don't have enough to put any more in the 3 groups. So I'm going to put a 3 in my answer, and that means I've used up 9 of my blocks. And when I subtract that, I have 2 blocks left over. And since we don't have any other place values to convert into, or at least not yet because we haven't learned about decimals yet, this is just our remainder or our leftover. And so our answer would be all of the place values in the groups added together. So we have 100 plus 5 tens plus 3 ones, and that gives us 153. and then we have a remainder of 2. And that's how we would show long division by 1 digit. And this algorithm that I just showed you is called the intermediate algorithm. So you might have noticed that usually when we do long division, we don't have a bunch of different numbers in our answer spot. We usually just have 1. But the intermediate algorithm can be really helpful for helping students understand why we divide things the way that we do. So let me go through kind of like how you would talk through the intermediate algorithm and explain what it would look like in block form. So if we had 3,159 divided by 7, I would have 3 thousands, 100, 5 tens, and 9 ones that I'm trying to split up into 7 groups. And I would do this in phases. So I would say, okay, well, let's start with the biggest place value and divide that up. Well, if I only have 3 thousands, I can't split it up equally into 7 groups. So that means I'm going to have 0 thousands in my answer. And then, since I have 0 thousands, that means that I'm going to take all of my thousands and convert them into hundreds, which means that I now have 31 hundreds. And that is enough hundreds to split up into 7 groups, because if I skip count by sevens, I have 7, 14, so 2 in each group would be 14 hundreds, 3 in each group would be 21 hundreds, and 4 in each group would be 28, but I don't have enough to put 5 in each group because that would be 35 hundreds. So I'll have 4 hundreds in each of my groups, and when I put 4 hundreds into each of my groups, that means that I've taken care of 28 hundreds. And so I can subtract 28 hundreds, which when I borrow from here, that gives me 3 hundreds, 5 tens, and 9 ones left over that I still need to divide. Then I can divide my next place value, which is my tens place value. And I say, okay, well, I have 5 tens, but I also have 30 tens from my 3 hundreds that I can't divide equally into 7 groups. So I have a total of 35 tens. And if I divide 35 tens into 7 groups, each group will have 5 tens in it. So that will be the 50. And when I put 5 tens in each of the 7 groups, that means that 35 of my tens have been taken care of. So I can subtract 350, which tells me that I have 9 left to divide. And if I have 9 ones left to divide among 7 groups, I can just put 1 in each group. 1 times 7, like because I only put 1 in each group, means that I've taken care of 7 of my ones, and I have 2 ones left over. And so my answer in this case would be 0 thousands, 4 hundreds, 5 tens, and 1 one, and I would have a remainder of 2. So that's what the intermediate algorithm looks like. The standard algorithm is very similar. You just cut out a couple parts that aren't necessary to write. So when you say that you have 3 thousands and you can't split them up into 7 groups, you just put a little 0 here. Then you say, okay, well, if I take those 3 thousands and convert them into hundreds and I have 31 hundreds, again, I can put 4 hundreds in each group. But instead of writing out the whole number 400, I'm just going to put a 4 in the hundreds column. So this is like where the shortcut part comes in, because you don't have to write out the whole number 400. And you say, okay, well, if I have 400s in each of my 7 groups, then that takes care of 28 of my hundreds. And we just subtract the hundreds and figure out how many hundreds we have left. So we have 31 hundreds minus 28 hundreds will leave 3 hundreds. And then you can either choose to have your students also like bring down the 5 and the 9, or it's also very common to bring down the next place value once you're ready to work on that place value. So you can bring down the 5 and say, okay, well, I have 5 tens, but I also have 30 tens from my 3 leftover hundreds. So if I take those 35 tens and split them up into 7 groups, that gives me 5 in each group. And if I put 5 tens in each of my 7 groups, that means that I've taken care of dividing out 35 of them. And so when I subtract those, I have 0 tens left over. Then I can bring down my next place value and my ones, and I have 9 ones to divide and 0 tens left over from my 10 step. And so if I take my 9 ones and divide it up into 7 groups, I can put 1 in each group. And then if I put 1 in each group, that takes care of 7 of my ones, so I can subtract those, and I have 2 ones that have not been divided yet. And that's what we would call our remainder. So again, you get the same answer, it's just the notation of how you write it out. So the main differences here are that in the intermediate algorithm, you're writing out the zeros that show what place value this is in, versus in the standard algorithm, you just allow the place value columns to communicate what place value it is. And same thing in the answer, rather than writing out 400, we just wrote a 4 in the hundreds column. And that's how you would do long division with either the intermediate algorithm or with the standard algorithm. But as with all of our lessons we've done so far, I would highly recommend teaching the intermediate algorithm first and then moving on to the standard algorithm as a shortcut for writing out the intermediate algorithm. Because the intermediate one really shows kids what's happening and why it's happening. And then the standard algorithm can just make it faster for them to write the process out. And then if you're doing multi-digit division, you want to help your students use their thinking strategies for multiplication as well as their estimation skills in order to figure out how many things go into each group. Because when you're dividing up into like 3 groups or 4 groups or something like that, you have all your times tables to help you. But with multi-digit division, like if you're dividing by 56, nobody really has their 56 times tables memorized. And so you'll want to help your students use their thinking strategies to make that process easier. So for example, on this one, if we have 4,238 divided by 56, well, I'd start off and I'd say, okay, if I have 4,000s, can I divide it up into 56 groups? Well, obviously not, because if I have 4,000s and I have 56 groups, I can't put 1,000 in each group. So I'm going to have 0 thousands in each group. Then I move on to my hundreds and I say, okay, well, if I take these thousands and convert them into hundreds, then I have a total of 42 hundreds. But that is still smaller than 56, so I can't put 100 in each group. So I'm going to have 0 hundreds as well. Then I'll say, okay, well, if I take my 42 hundreds and convert them into tens, well, then I'm going to have 423 tens. And that can be split up into 56 different groups. But in order to figure out how many groups or how many tens will go into each group, I'm going to use some of my thinking strategies to help me think about it. So I may use an estimation tool and say, okay, well, if I have 423, like ultimately I'm looking for 423 divided by 56, but maybe I could estimate this to be about maybe like 400 divided by 50, because that's way easier. Because if I do 400 divided by 50, that should be, 40 divided by 5 is 8. So 400 divided by 50 would also be 8. And this is a division skill you can teach your students. And then we just want to check and say, okay, so an 8 might be a good estimate. So we're thinking that 8 might be a good guesstimate. And so we'll say, okay, well, if I put 8 in each of my 56 groups, I can model that with 56 times 8. And if I make 8 copies of 6, that's going to be 48. And the 40 can be converted into 10, so I'll carry the 4. And if I make 8 copies of 5 tens, I'm going to have 40 tens plus the 4 tens that I carried, and I'm going to have 448. Now that, I don't actually have that number of tens because I only have 423 tens, and it would require 448 tens in order to put 8 in each group. So my estimation number was not quite right, but it gives me a good spot to start. And then I can say, okay, well, 8 doesn't work, but I could do 7 in each group. And if I do 7 in each group, 56 times 7, that would be 42 ones. So 40 of the ones can be converted into tens. So I'll put a 4 in the tens column. 7 copies of 5 tens would be 35 tens, plus the 4 tens would be 39 tens. And sure enough, I do have enough to do that. So I'm going to subtract the 392 tens that I split up into the 56 different groups with 7 in each group. And when I subtract that, I get 1 10 left over in that column, and then I'll borrow from here. That's a 3. So I have 31 tens left over. So I'm going to convert those 31 tens into ones and also include these 8 ones from the original problem. And now I need to divide 318 by 56. So I know for sure that I'm going to put less than 7 in, because if I put 7 into each of the 56 groups, I get 392. And I don't think that I'll be able to put 6, but let's maybe try 5. So if I do 56 times 5, 5 copies of 6 ones is 30 ones. So I'll have 3 tens and 0 ones. And 5 copies of 5 tens is 25, plus the 3 tens would be 28 tens. So I would have 280 ones taken care of if I put 5 ones in each of my 56 groups. So if I put 5 ones in each group, that means I'm taking care of 280. And when I subtract that, I get 8 ones. 31 minus 28 will give me 3. So I have 38 ones left over. And so that would be my remainder, because that's the amount that I can't divide into the 56 piles. Now, sometimes it's possible that your estimate might be too low. Like if I had chosen 4 here instead of 5, then this number would have been smaller and my remainder would have been bigger than the number I was dividing by. So if your remainder is ever bigger than the number you're dividing by, that just means that your estimate was too low and you need to increase it. Because if you have enough leftovers to put another 1 in each of the groups, then you should do that, because the remainder is just what you can't divide up equally. So that's how you would think through multi-digit division. And another way you can also think about this is by doing repeated subtraction. So the idea of repeated subtraction is to subtract groups of 45 until you can't subtract them anymore. So for example, in this problem, I could take 3,256 and subtract 45 over and over and over and over again until I can't subtract 45 anymore. And then however many times I subtracted it, that would be the answer to this problem. However, there is a little bit of an easier shortcut than just subtracting 45 tons and tons of times, because I can also subtract like 10 groups of 45. So rather than just subtracting a group at a time, I can subtract them in increments that are easy to calculate. So for example, in this one, I might say, okay, well, I know that in 3,256, I have enough to make 10 groups of 45. And 10 groups of 45 would take away 450 from this number. And so this is 10 groups of 45 that this is representing. And when I subtract that, I get 6, 0, and 32 minus 4 is 28. Again, I still have enough to subtract another 10 groups of 45, so I'm going to do that. And that gives me, let's see, I'd have 6, 5, 3, and 2. Then again, I have enough to subtract 450 again, so I'm going to subtract another 10 groups, and that gives me 6, 0, and 23 minus 4 is 19. So that's another 10 groups. And then I'm going to rewrite this up here because I'm running out of room, but I have 1906. Again, I still have enough to subtract 10 groups of 45, so I'll subtract that, and I get 6, 5, that's an 8, so 4, 1. Then I can also subtract another 10 groups of 45, which is 450, and that gives me 6, 0, 0, 1. Still have enough to subtract another 10 groups, so I get 6, and let's see, that'd be 5, 5, so 556. And again, I still have enough to subtract another 450, or 10 groups of 45. So that gives me 6, 0, and 1. Now at this point, I can't subtract any more groups of 10 45s, because 10 groups of 45 requires 450, and 106 is less than that. But now I can subtract in increments of 45. So I can subtract 45, and that gives me 1 and 6. That is enough to subtract 45 again, and that gives me 6 and 1. And now at 16, I can't make a group of 45 out of 16. And so that's going to be my remainder. And I should have written this as I was going. But basically, these two steps of subtraction were one group of 45, and all of these other 450s were 10 groups. And so the way that I figure out my answer to 3,256 divided by 45 is I say, okay, well, I had enough to make 10, 20, 30, 40, 50, 60, 70, 2 groups of 45. And so my answer is 72, remainder 16. Because when I subtracted groups of 45 from the amount that I had, I was able to make 72 groups, and then I had 16 of my numbers left over. And so that's another model that you can use, and it's more useful, in my opinion, with multi-digit division versus one-digit division, because the one-digit divisions are easy to show with blocks, but when you have, like 45 piles and these huge numbers that you're trying to divide, a model like repeated subtraction can be a helpful way to think about it. So that's it for this lesson. If you have any questions, let me know.